Good morning. This is Professor Ghosh. I teach 20th and 21st century literature in the English department, as well as science and technology studies. And thank you to Professor Donnelly for inviting me to this book club. And I wanted to actually bring you two books, quite famous books, of science journalism, which is a genre which might interest some of you as English majors, because it's really largely a genre that brings the scientific research on epidemics and pandemics to heterogeneous publics. So I want to talk about two books today, and I'm going to share my screen because I have a couple of images. Um, Laurie Garrett's The Coming Plague and Sonia Shah's Pandemic. So give me a minute while I start my screen share. Okay. Right. So I really want to talk about these two books, and they are historically 22 years apart. And I want to talk about them in reverse order for reasons that will become clear. Now, The Coming Plague was written by Laurie Garrett. You may know her as a Pulitzer Prize winning journalist who she was writing in Newsday in 1994 about the sudden resurgence of deadly bugs, Marburg, Hanta, Ebola, HIV, these viruses that had suddenly broken out in the late 70s and early 1980s. And they created a consternation around emerging infectious diseases. And Laurie Garrett writes this book, which historically scared the wits out of all the audiences that read or encountered what was in its massive 600-page interior. And then Sonia Shah writes a Pandemic about 22 years later in 2016. And her book is interesting in tracing back sort of the history of epidemiology. Whereas in modern science, the first sort of epidemic that's really focused on is cholera. And so these two books kind of bookend how we've been thinking about the virus. I'm sure after COVID-19, there will be many more. Now, I wanted to start with a sort of a quick definition. I've been writing a book called The Virus Touch that's right now unpublished and I'm still finishing it. But I wanted to sort of start with the notion of the epidemic, which comes from the Greek word epidemia, which means a condition against the demos. And the epidemics seem against the demos of the people anthropocentric in focus, right? But yet they're actually quite something else. They, in the history of the virus, the first viral epidemic was actually noticed in plants, in the tobacco plant, and it was called the tobacco mosaic virus in 1892. And epidemic is a generic term for a widespread disease incidence at a given point of time. And we could think of the pandemic as a particular global form that this takes. In 2009, in What is a Pandemic, a very famous article, you'll notice Dr. Fauci as one of the authors, the NIH designated 8 criteria that defines a pandemic, which includes wide geographic extension, minimal population immunity, and contagiousness, among other things, right? So that's sort of definitional. But what is interesting about the epidemic is you can track it to the biological actions of parasitic microbes, SARS-CoV-2 in our time, which is a matter of global concern. But the concerns are scientific and technological and social and economic. In other words, epidemics are crisis events which we think of as emergences, that they're multi-leveled occurrences that are both economic. People who are getting ill don't have proper health care, so there are comorbidities. We know the story, right? So the occurrence actually happens at many scales and in many domains, so many that it boggles our minds to keep abreast of them. And some of these works of science journalism, of course, help us do that. But to go back to the beginnings of epidemiology, which is sort of the science of epidemics, And the most important figure here is Jon Snow, who was tracking the cholera outbreak in London. And he tracked it, interestingly, to one pump, as you see here on Broad Street, where this woman who used to get water only from this pump because she used to like the taste of it, and how she got ill. And then he begins to realize it's water from there and what was in the water, etc., etc. So this is sort of the beginnings of placing diseases in particular milieus and trying to look at what exactly is happening in the disease milieu. So Sonia Shah begins her book with with modern science, and she talks about actually the beginnings of cholera. And what is interesting about both Garrett and Shah is that they actually look at epidemics in their primary transmission, that is when they first occur or explode, um, as sometimes in disturbance in ecological systems and ecosystems. And then they enter what is called secondary transmission, that is between human and human, or plant and plant, or animal and animal. And we are, of course, now with COVID-19 in a massive secondary transmission period. So she begins her book with cholera starting out in the bodies of animals. And I'm reading from page 18 of the pandemic. The creatures that harbored cholera live in the sea. They're a kind of tiny crustacean called copepods. They're about a millimeter long, with tear-shaped bodies and a single bright red eye. Since they can't swim, they're considered a kind of zooplankton, drifting in the water and delaying gravity's pull to the depths, with long antennae splayed outwards like wings on a glider plane. Though they are not talked about much, they're actually the most abundant multicellular creatures on Earth. A single sea cucumber might be covered with over 2,000 copepods, a single hand-sized starfish with hundreds. So you see here in Shah already bringing you many, many particular facts, but sort of transmitting it in this sort of evocative language that sort of places you in the sea environment. So to continue, Vibrio cholera, says Shah, are their microbial partners. Vibrio cholera are a microscopic comma-shaped species of bacteria from the genus Vibrio. Although Vibrio cholera can live on its own, free-floating in water, it collects most lushly in and on copepods, sticking to the copepods' egg sacs and lining the interior of their guts. Vibrio bacteria performed a valuable ecological function there. Like other crustaceans, copepods encase themselves in crusty exteriors made of a polymer called chitin. Several times during their lifetimes, they shed their outgrown skins like snakes, discarding 100 billion tons of carpaccios annually. Vibriobacteria feed on this abundance of chitin, collectively recycling 90% of the ocean's excess chitin. Were it not for them, copepods' mountains of exoskeletons would starve the ocean of carbon and nitrogen. Vibriobacteria and copepods proliferated in the warm, brackish coastal waters where fresh and salty waters meet, such as the Sundarbans, and expansive wetlands at the mouth of the world's largest bay, the Bay of Bengal. So, in this first description, you have that's a sort of the global territory, but you also have a disease milieu, right? An ecosystem in which Vibrio cholera and the copepods lived sort of off each other as beneficial partners, right? But this begins to change when human activity disturbs this ecosystem. So she says in the 1760s, the British East India Company took over Bengal and with it the Sundarbans. English settlers, tiger hunters, and colonists streamed into the wetlands. They recruited thousands of locals to chop down the mangroves, build embankments, and plant rice. Within 50 years, nearly 800 square miles of the Sundarban forests had been razed. Over the course of the 1800s, human habitations would sprawl over 90% of the once untouched, impenetrable, and copepod-rich Sundarbans. And then she goes on to talk about the 1817 first outbreak of cholera in Jessore, which is in this Delta area. And she talks about this intimate contact allowed Vibrio cholera to spill over or jump into our bodies. Vibrio cholera became what's known as zoonosis. This is Virchow's designation in the mid-19th century, from Greek zoon for animal and nosis for disease. It was an animal microbe that could infect humans, but Vibrio cholera wasn't a pandemic killer yet. And this is then Sonia Shah goes on throughout the book to describe exactly how Vibrio cholera then makes it to London, so that we have that cholera outbreak in the mid-19th century. And mostly it's British soldiers who are infected in India travel on steamships, which prove to be excellent breeding grounds for Vibrio cholera, and the microbe makes it all the way across the world. So global transportation systems, along with this primary transmission, the zoonotic skip, creates this cholera outbreak, and then you have the beginnings of what we understand today as epidemiology. Now, of course, this is a kind of an ecological and global reading, and it is one, of course, that is very pertinent to the current episode. We know, of course, that SARS-CoV-2 has been circulating in bats for decades, horseshoe bats in particular. These are our primary animal reservoirs. And bats actually have a high biodiversity of viruses because they have extremely high metabolism. So their immune system can actually live with viruses with far greater ease than we can. And so when it skips into humans, the virus becomes rather deadly. So we've been tracking how it gets from horseshoe bats into human populations. That chain of transmission is, of course, where we can always intervene. So the point that Shah and Laurie Garrett are making is an ecological point, that these microbial entanglements are inevitable and we'll have to live with them. But of course, what we can mitigate is this chain of transmission, so that you have the sequential infection can be halted, like we're trying to do now with COVID-19, or actually change some of our habits of deforestation, of extractive mining, of illegal wildlife trading, practices that can be curtailed and prevent these new opportunities for these bugs. The other part of the story, which I can't really go into in greater depth here, has been sort of these excavations in these abyssal caves in New Mexico and elsewhere, in which you have bacterial and viral colonies frozen and dormant in crystals. Now, with climate change and global warming, you have some of these crystals begin to melt, as well as the permafrost. And you've heard of this in Siberia, perhaps. And these are releasing enormous amounts of new microbes into the Earth's upper crust. So this is sort of the climate change story of microbial entanglements. And one of the most interesting figures here is Dr. Penelope Boston, who's an astrobiologist, and she's been working on these microbial colonies in the caves. Anyway, so to close, I want to read a little bit of Laurie Garrett's 600-page book. It's an amazing book, and you can read a few chapters. One doesn't have to go through the entire book, but it's very interesting to me because it's a book that warned us about coming plagues way back in 1994. And she begins the book with her uncle Bernard, who was 7 years old when the 1918 influenza outbreak happens. And he grew up as a child watching the deaths in that influenza epidemic. In the mid-20th century, he joins the Army Medical Corps. And he is then, of course, elated by this idea of a utopian world in which humans have won the war on germs. And Laurie Garrett begins her book with him because in 1976, with the emergence of Ebola in Zaire and Sudan, and this is one of the first images of Ebola, things, this whole dream of winning the war on germs, something incidentally that we're seeing again now with talk of an invisible enemy, this comes crashing to an halt. So let me read from Garrett. During the summer of 1976, I had reason to reconsider much of my Uncle Bernard's wisdom. As I tried to make sense of my graduate research at Stanford University's Medical Center, the news seemed overfull of infectious disease stories. The US government was predicting a massive influenza epidemic that some said would surpass that of 1918. An American Legion group met in a hotel in Philadelphia on the 4th of July, and something made 182 of them very sick, killing 29. Something else specially strange was going on in Africa, where, according to garbled press accounts of the day, people were dying from a terrifying new virus. In Zaire and in Sudan, something called the green monkey virus or Marburg or Ebola, or a mix of all three monikers, was occupying the urgent attention of disease experts all over the world. In 1981, Dr. Richard Krauss of the US National Institutes of Health published a provocative book entitled The Restless Tide, The Persistent Challenge of the Microbial World, which argued that a disease long thought to have been defeated could return to endanger the American people. And so you see here in Garrett's prose a different kind of history from Shah's, a history of how we came to know these emerging infectious disease. And she talks about a very famous 1989 conference hosted by a young virologist, Stephen Morse, and the Nobel laureate Joshua Lederberg, who had once said that microbes are the greatest, deadliest threat to humankind. This conference, which took place in Hotel Washington, right opposite from the White House, had 3 days of discussion on providing evidence that disease-causing microbes of the planet, far from having been defeated, were posing ever greater threats to humanity. And I'll read one excerpt from this. University of Chicago historian William McNeill outlined the reasons Homo sapiens had been vulnerable to microbial assaults over the millennia. He saw each catastrophic epidemic event in human history as an ironic result of humanity's steps forward. As humans improved their lots, McLean warned, they actually increased their vulnerability to disease. It is, I think, worthwhile being conscious of the limits upon our powers, McNeill said. It is worth keeping in mind that the more we win, the more we drive infections to the margins of human experience, the more we clear a path for possible catastrophic infection. We'll never escape the limits of the ecosystem. We are caught in a food chain, whether we like it, eating and being eaten. So then, of course, the rest of the book proceeds with giving us the various kinds of outbreak narratives and the science that emerged out of this episode. And of course, she ends the book by saying, as the world approaches the millennium, remember she's writing in 1994, it seems from the microbes' point of view as if the entire planet occupied by nearly 6 billion, mostly impoverished Homo sapiens, is like the city of Rome in 5th century BC. The world really is just one village. Our tolerance of disease in any place in the world is at our own peril, Lederberg said. Are we better off today than we were a century ago? In most respects, we are worse off. We have been neglectful of microbes, and that is a recurring theme that is coming back to haunt us. So Garrett ends the book saying, while the human race battles itself, fighting ever more crowded turf and scarcer resources, the advantage moves to the microbes' court. They are our predators, and they will be victorious if we, Homo sapiens, do not learn how to live in a rational global village that affords the microbes few opportunities. It is either that or we brace ourselves for the coming plague. And of course, as we are now in 2020, we are in the midst of one of these coming plagues. So I encourage you to read some of these books in science journalism. They are extremely informative, they're evocative, and they're historical. So happy reading, and thank you.